Assalamualaikum warahmatullahi taala wabarakatuh. Today we will present about static and dynamics group projects. We are from section 2, group 8. So before we start our presentation, I will introduce our group members. I Muhammad Hafiz bin Rijaluddin, and then Nur Humaira binti Wazir, Nur Afika binti Muhammad Amri, Nur Sahira binti Muhammad Zaini, and lastly Muhammad Izzat Izahar bin Mat Zaid.
For introduction, our study area covered pedestrian walkway, Pago Education Hub, Sport Centre. First is serves as a sheltered road connecting parking area, main building and sport facility. Second, steel roof supported by vertical column transferring load to the concrete foundation. Third, protect pedestrian from rain and strong sunlight, especially during peak activity. It's exposed to dead load, left load and wind load due to its open elongate design. For last, ideal for demonstrating static principle, equilibrium of force, load distribution and support reaction. The objective of this study are as follows. First, to identify the structural element, force and support condition acting on the covered pedestrian walkway. Second, to apply principle of static including equilibrium equation and free body diagram in analyzing the selected structure. To determine the reaction, internal force and moment acting on the roof and supporting column. To enhance understanding of the real-world application of static in civil and structural engineering.
The next, problem identification. For the problem identification stage, we begin by understanding the overall structure under study. The structure selected is covered pedestrian walkway at Pago Education Hub, which consists of a steel roof system supported by steel columns. The structure is analyzed under static equilibrium, focusing on the applied loads, support condition and force transfer mechanism. Number 2 is selected structure scenario. The selected structure scenario is the steel roof spanning along the pedestrian walkway. The roof is supported by vertical steel columns where all loads from the roof are transferred down to the ground through the columns and foundation. For analysis purpose, one roof segment is simplified and modeled as a beam. Next, number 3, the force acting on the structure are identified. The first force is the dead load, which represents the self-weight of the roof system. The second force is the life load, which accounts for maintenance activities such as inspection and repair works. In this analysis, the life load is taken as 1 kN per square meter and all loads are assumed to be uniformly distributed. Okay. Number 4 is the support condition. The support condition are idealized to simplify the static analysis. One end of the beam is modeled as a pin support, while the other end is modeled as a roll support. This idealization allows the application of equilibrium equation while maintaining realistic structural behavior. And finally, number 5, the structure is represented using a free body diagram. The free body diagram shows the uniformly distributed load acting downward and the reaction force at the pin and roller support.
Next, we will discuss the analysis. Several assumptions were made to simplify the analysis. The structure is in static equilibrium, materials are linearly elastic and deformations are neglected. Roof and leaf loads are treated as uniformly distributed, wind load as horizontal UDL, and connections are ideal. pin support only vertical and dynamic effects are ignored. Based on the free body diagram, the structure was analyzed using the equations of static equilibrium. The sum of vertical forces acting on the structure is equal to 0. The sum of horizontal forces acting on the structure is equal to 0. The sum of moments acting on the structure is equal to 0. These equilibrium equations were used to determine the unknown reaction forces at the pin and roller support. Next, we move to the calculation. The total load is 1.94 kN square made up of dead load and lift load. This load creates a point load of 9.83 kN and a support reaction of 4.92 kN. The roof used two beams with 2.9 meters spacing and each beam carried 2.73 kN square. We look at how the roof load is distributed across the structure. Each section of the roof contributes to the beam, so we calculate the load for each part. Then the distributed load is converted into equivalent point loads at specific location on the beams. This helps us simplify the analysis and know exactly how much load each part of the beam carry. By adding up these point loads, we get the total load acting at each support. Next, we determine the dead load of the roofing sheet and the spandex material. The total mass is converted into force to get the load per unit area. Then the supporting steel beams cross-section is used to calculate its self-weight. The beam self-weight is added to the roof load to get the total load acting on the beam. The incline length are calculated using cosine 20 degrees, giving values of 1.13 meter, 2.26 meter, and 3.38 meter. Since there are no horizontal load, the sum of horizontal forces is 0. Next, the sum of vertical forces is applied to find the support reactions. By taking moments about point A, the reaction force at support Y is calculated at 4.82 kN. Using this value, the reaction at support A is found to be 8.08 kN. The calculated support reactions show that the structure satisfies all static equilibrium conditions. This confirms that the beam and supports are capable of resisting the applied load safely.
Next, I will explain about the assumption. The structure is assumed to be in a state of static equilibrium, meaning there is no movement or acceleration acting on the system. Any structural deformation is neglected, and all structural members are considered rigid. The self-weight of the roof and the lift loads are assumed to act as uniformly distributed loads, which is UDL. Wind load is simplified and treated as a uniform horizontal load acting on the structure. In terms of support conditions, ideal supports are assumed. A pin support is considered capable of resisting both vertical and horizontal forces, while a roller support resists only vertical force. Load transfer between the roof, beam, and columns is assumed to be perfect, with no loss of force. Dynamic effects such as vibration or impact are neglected, as all loads are treated as static. In addition, the foundation is assumed to be completely stable, with no settlement or rotation occurring.
For the conclusion, the study applies static principle to analyze a covered pedestrian walkway at Pagoh Education Hub Sports Centre. Other than that, we also calculate loads transfer from the roof to beams and to columns and foundation. Was clearly identified using free body diagram and equilibrium equation. The analysis confirmed that the structure is stable and satisfies static equilibrium under assumed loads. Overall, the study highlights the importance of static in engineering, structure, safety, and understanding real-world engineering systems. So that's all from us. Thank you.